Now let's look at question 631. That is on page 321. In this question, an astronomer notes that during the meteor shower, an average of 50 meters appears each hour. So the mu is 50, with a variance of 9 meters. Variance. And in Statistics Year 1, we have learned variance is standard deviation squared. So that is the squared standard deviation. If it is for the populations, then that will be the squared sigma. So the squared sigma will be 9, which also means that the population standard deviation is 3. And if the astronomers watched the shower for 4 hours, so he picked up 4 hours for his research, and the sample size is 4. So we have known from this question is the population mean 50, the sample size 4, the population standard deviation 3. And what we are going to know is what is the probability that at least 40 meters means larger than 48 per hour will appear. And if we visualize it, you can find that the population mean is in the middle. So this is 50, and 48 is lower than 50, so it is somewhere here. And we want to know at least 48. What is the probability? So that means the probability, our value larger than 48. So this is something we are going to solve. Okay, and we know that first we need to calculate the standard error, and the standard error comes from the population standard deviation divided by the square root of the sample size. And this sigma comes from the square root of our variance, because this is the variance and this will be the standard deviation, and divided by the square root of the sample size. So that will be the square root of 9 and divided by the square root of 4, that is the sample size. So we get 3 divided by 2, 1.5. This is our standard error. And after that, we can use the z-score equation to get your z-score. It comes from the x bar minus the mu and divided by the standard error. We know that x bar is 48 and the mu is 50 and the standard error will be 1.5. So you get minus 2 divided by 1.5. So you get minus 1.33. And if you check the table, you can find the p-value is 0.4082. And it has not finished yet, because when we visualize it, we found that the population mean is here and our x bar is here. We want to know the probability larger than 48. So this part is 0.4028, while this part is 0.5. So when we add them together, then we get 0.9082. So this is the final answer for this question.